Welcome back. Pieces of wood floating in water. Here are pieces of wood moving apart. The water rises between the blocks. It's just what's going on in the middle of the Atlantic and in the Pacific and in the Indian Ocean. Now, on a passive continental margin where you don't have the leading edge with all the earthquakes, you get huge amounts of marine sediment. You may get covered reefs. You can get rock salt under there and lots of faults where this stuff has slid down. Remember this from the ocean chapter? Here's the margins with the shelf, the slope, and the rise. You don't see this on the active plates or on the active margins. This is your book's summary of the three types of boundaries. We started talking about divergent, we'll talk about convergent, and transform. Here's a transform fault in California where the two plates are moving past each other. The western part of California is actually part of the Pacific plate, and it's going north. The rest of this is going south relative to the other. Convergent plate boundaries. In convergent plate boundaries, the plates move toward each other. Here we have an ocean plate hitting an ocean plate. One of them has to give way, like two football players. Okay, sometimes they just stand up and fall back, especially in comedy movies. But in this case, this ocean plate is going underneath. It's subducting. As it subducts, it takes with it water. The water lowers the melting point of the basalt, and the basalt begins to melt, becomes less dense, and starts to rise. So right next to a deep sea trench formed by subducting plates, you find island arcs. Think of Jakarta, Indonesia, that kind of thing. The Aleutian Islands, and the entire series of seamounts underneath the Atlantic. Not all of these seamounts make it to the surface. When you have an ocean crust subducting underneath continental crust, again you get volcanoes and mountain ranges. You get a trench off here. Here's a picture from your book, and it shows that when you have continent hitting continent, you end up with wrinkles like the Himalayas, which still are growing up at about 2.5 inches or 5 centimeters per year. Now, even the plate boundaries themselves migrate over time, and I don't want to cover this a lot. It's not a big deal. Here's what is significant. When the plate that's the ocean sinks underneath us, pieces get scraped off. All those wrinkly hills on the west coast, California, Oregon, Washington, those are exotic terrains or pieces of land that don't really belong to the continent. They're just stuck on there. Imagine sliding your hand across a dusty floor. What's going to be along the leading edge of your fingers? A lot of dust. Well, this is like the dust of our continent scraping across the ocean floor. Often you get a basin, like we see in the western United States, and, granitic mountains like we see in the Sierra Nevadas, and batholiths. And with these batholiths, you get a lot of metals and lots of mining going on in this area. Back here is the original continental crust called the craton, the old part of the continent. Whereas this, it's back in the northeast United States and Canada. It's on the trailing edge of our continent. Here's another vision of the same thing, but in this case you have ocean hitting ocean and an island arc forming. Okay, once again, cover it again. This is what causes plate motion. The lava land, essentially. Mantle plumes rising, spreading apart the continental crust. You have ridge pull along the mid-ocean ridges, and you have slab pull, where slabs getting pulled down back into the earth, which is a little bit of a misnomer, at trenches. Your book really likes to go into that. It's not a big deal. Okay, when we have rising mantle plumes, it will lift the continent, it'll crack the continent, and then you end up with these flood basalts, lavas, on top of the continent. Sometimes you get a dome and then that three-way splitting like we were just talking about off the Red Sea, the Gulf of Aden, and the Rift Zone of Africa. There are plumes rising in this example, creating flood basalts, and that's what's going on right here. If you ever go to this part of Africa, you're going to see lots of black basalt rock. Now, we always talk about Hawaii being a hot spot, but there are a lot of hot spots on Earth. Here's Hawaii, of course, but all these are various places where plumes seem to be coming up and splitting the Earth. Here again is the AFAR triangle, which we just showed you. Here's Hawaii. Here's the oldest island. Here is the newest island. This one has fairly good reefs. This one has very small reefs around it. This is a reverse picture from here. This is looking back toward the southeast. This is looking toward the northwest. Right now there's a fixed hotspot underneath Hawaii. The plate itself is moving this direction. So this is the youngest volcano. This used to be the youngest. And even right now there is a volcano or an island trying to form off of Hawaii. Midway, by the way, is something like this. And here is a picture of what's going on. Hawaii, 14,000 feet out of the water. As you go over here, Midway is just barely out of the water. As we go over here, these guys are underneath the water. Ages of the islands, take a look. Somewhere around 5 million. Right here, recent. Now this is kind of cool. Every time you have one of these plumes, you get ore deposits. We've talked about this before. Water coming up will dissolve metals and redeposit the metals. And sometimes in these currents underneath the ocean, you can get ores in the sediments. Also, as the basaltic crust subducts, different metals will come out at different depths. So as we start to mine in the western United States, we find tungsten and copper and lead and silver in different places. Examples: we mine tungsten in California. Porphyry coppers we mine in Arizona and Nevada and Utah. Lead, silver, and zinc we tend to mine over in Colorado and New Mexico. Cool, huh? This stuff really works. Here's an example of the stuff being brought up in those plumes. This is in California. And one last thing, here is the craton, also known as the shield. This is the oldest rock of our continent. Well, that's it. Thanks for watching.